All right, everybody, welcome back. Today we're going to be going through and we're going to start actually placing numbers on the unit circle via this unit circle activity. So this lesson is going to look a little bit different than our traditional notes. I want to kind of go through and show you how we develop this. Now, in terms of assessments on this, it's very hard for me to sit there and give you like a homework assignment because you can just come back and look up all of your answers. What's really more important here is that you have a good understanding of what we're actually discussing and how we come about and find the answers that we are. Now, when we are looking at the unit circle, it's important to understand what the unit circle means. This is a circle that is centered around the origin. So the origin being 0, 0 over here, in which every point on the circle is 1 unit away from the origin. So over to here, we would be 1 unit away. Over to here, 1 unit away, 1 unit away, 1 unit away. Now, for each of the 4 directions, since we know a little bit about a Cartesian plane, what we do know is that if we are 1 unit away from the circle, we didn't move up or down in this first situation. What actually happened here is we just moved 1 unit to the right. So we do know that this coordinate over here is the coordinate 1, 0, because we are 1 unit away from the origin of the circle, the center. Now, if we moved 1 unit up from the center of the circle, we didn't move anywhere in the x direction, so we know our x coordinate is still going to remain 0, but our y coordinate is now going to be 1. Coming over here to this guy on the left, if we moved 1 to the left over here, since we did move left from our origin, we know that we'll be at -1, but we did not move up or down, so we're going to remain at 0 there. Finally, looking down here at the bottom of the circle, if I moved 1 down from the origin, then I would be at 0, -1. My x did not change, but my y went down 1. Now, that's pretty straightforward, but where this actually gets harder is trying to find the measurements or the locations of the points where maybe we aren't just going in a straight direction, but we kind of approach diagonally. And that's really where we're going to be focused on today. Now, the truth of the matter is that in any of these situations, so each of these yellow lines is still going to be 1, right? So this is 1 because the radius of a circle is the same regardless of where it is. So whether it's out, to the right, up, down, it's always got a radius of 1, and that includes if we are approaching with these angles, right? So these all have unit measures of 1. Now the problem is actually trying to identify the coordinates of each of these, and that's what we're going to be focusing on today. Now, a couple things to know. There is a very big relationship between multiple of these, and really the biggest thing is the sign that's going to be changing on them for the most part. So what's really important here is that you can understand where we get the numbers that we do, but also how they play together and work with one another, because typically what's going to happen is you are not going to want to try to come through and memorize each and every single point on the unit circle. Instead, you want to sit there and try to develop, normally, I mean, at least what most people do is they try to develop 3 of them, and then they try to use each of those 3 to sit there and map out the other ones. Now, like I said, this is hard to assess you on, so I very well know you can just look up a picture of the unit circle online and you can sit there and grab the numbers off of that. But when we get in person, you're going to be taking a test on the unit circle, and that's going to be where you're going to literally have to write down all of this information on your own with no resources. So it's important to know where it comes from. Now, where each of these measures comes from is from the special right triangles that we've developed. Kind of, it feels like so long ago, but we've been talking about them continually. So the first special right triangle that we have here is the 30, 60, 90 triangle. And one thing you'll notice is that this triangle has been constructed in such a way that the hypotenuse of it is 1. And that fits in because we were talking about the unit circle. So that is 1. But what we really want to know here is we want to know, well, how big is each side of this triangle? So in this situation, if we know the hypotenuse is 1, we can use our formula up here that we developed earlier. So if our hypotenuse is 1, that would be equal to the short leg of the triangle, let's just call that x, times 2. To solve this, we would just simply divide by 2, and we would quickly find out that x is really equal to 1/2. Now, Once we know that side, that actually allows us to unlock the long leg of the triangle. So the long leg of our triangle is just equal to our short leg times the square root of 3. So our short leg here was 1/2, and if I multiply that by the square root of 3, well, this is square root of 3 over 1, so I would get 1 times square root of 3 would be the square root of 3. 2 times 1 would be 2. So what we're going to find is that the bottom of this triangle, or the long leg, is 3 square roots over 2. Now, what I've done here below is I've taken kind of those same measurements, and I've just created the 4 different triangles that I could get by reflecting that triangle either across the x-axis or the y-axis. So in this first one, you can see that the triangle I had, I flipped it just down, right? I flipped it over. For the triangle below that, I flipped it across, and then we got our answer. For the one below that, I flipped it across, and then I flipped it down. And finally, for the bottom one, I just flipped it down. Now, or actually, I guess I should say the bottom triangle is actually just the original one. Those are our 4. Now, what we want to do is we want to carry our measurements through. So we know that the short side of this triangle is always going to be 1/2. So I'm going to have 1/2, 1/2, 1/2, 1/2. And then I know that my hypotenuse is always 1 in each of these triangles. I know this is my 30-degree angle, my 30-degree angle, 30-degree angle, 30-degree angle, and I know this is my 60-degree angle. Of course, this is my right triangle, or my right angle, I should say, my right angle, my right angle. And then the last thing we found is that the long leg of this triangle was the square root of 3 over 2. So that's going to follow suit on each of these. Square root of 3 over 2. Square root of 3 over 2. Square root of 3 over 2. Now, the reason that's important is because each of these 4 triangles, and really what the activity wanted you to do is to cut this out. So I'll show you another video of another teacher going through and physically cutting out these 3 triangles here and placing them on there to develop the unit circle, but I can't do that since I don't actually have a piece of paper here to drag in front of you, but I can drag these shapes. Each of these triangles is going to fit on the unit circle in a specific spot. And when we fit it in the right spot, what we're going to notice is that the triangle is going to hit one of the points that we were looking for. So in this situation, what we can see is that if I were to place this triangle with it being centered on the origin, the corner point up here hits exactly where that point was. That's because this point was developed from this special right triangle. Now, we can find the coordinate of that point just using a little bit of common sense. So what we know is that that point is this distance away from the center of the circle. So in this situation, we already found that distance to be the square root of 3 over 2. That's the distance x it is away from the origin. So using what we know about the Cartesian plane, we know that we can say that this is 3 square roots of 2 as the x coordinate. Now, we also know that that point is located 1/2 units up from our axis. So we know that this value will be 1/2. Now, what we're going to do here is we're going to repeat that process a couple of different times. So I'm just going to kind of keep this triangle and I'm going to pull it on, copy this. Actually, I think I can just move it. I'm going to move that triangle on down. We've already used this one now. So now what we want to do is we want to find another one. So coming over here, let's just grab the next one in line. So if I were to drag this on up to my unit circle, we're looking for where it can kind of fit in here and everything kind of matches up. And what we notice is that right here, we end up hitting this point down here in the corner. So let's use what we know. Well, in this situation, we went backwards, square root of 3 over 2 units. So we know that we'll have a negative square root of 3 over 2. And we went down negative 1/2 units. Now, like I said before, there's definitely a big pattern with these. And if you look at the actual coordinates that we've developed so far, there's a lot of similarities there. Now, we're going to have to try to map and understand what's actually happening with those to really understand the full picture. But for right now, we can start to generate what these values are. And hopefully you're seeing where they are coming from just from these special right triangles that each are going to have a hypotenuse of 1. If we grab our next triangle over here, now coming up here, one thing that you're going to want to work here is that one of your sides of your triangle is actually going to sit on the axis. So in this one, this is kind of an odd one, and we'll get to this in a minute, but there's something else that's going on right here. So we'll get to that. But over here, if you notice, this triangle kind of fits perfectly into this situation, and it helps to give us the location of that coordinate. Now what we notice is that since we are in the positive direction here, this would be the square root of 3 over 2. And since we are going downwards here, this would be a negative 1/2. Now again, I said this earlier, there is a very strong correlation between each of the coordinates that we are getting here. And maybe you can see that even more clearly on this one because of how closely related these two are, with the difference only being that negative sign. Delete. Oops, I did not want to delete that. I'm keeping these, I think. So let's pull this one down. Let's go to our next one. So we've used this one now. The only one we haven't used is this one. So let's copy this. And I think this one will fit right here. Each of these triangles should give us one location in each of the coordinates. And this one does too. It looks like in this situation, we need to go backwards, square root of 3 over 2. So that's going to mean negative square root of 3 over 2. And we need to go upwards 1/2. So 1/2 will be sitting right there, and that will be positive. Now, a couple of things maybe that you can notice and pick up on right now. The values for this triangle are obviously all just basically the same numbers repeated in a different order or with a different sign. So it's important to realize a couple of those different things that are coming from here. Now, one thing we do know is that the location of this one, right? So every time we put that triangle on here and we drew it, we had a 30-degree angle happening right here, right here, right here, and right here. And that's kind of helpful for us as we start to think about the degrees. Today we're primarily focused on just the coordinates. Tomorrow we're going to sit there and introduce the degrees a little bit more. But each of these has a 30-degree angle that they're opening up for, which is helpful as we start to kind of think about that. Now, other things to notice, right? In this first coordinate or quadrant here, ways I like to remember this is I always like to look at this and I like to think to myself, well, if it's 1 all the way up to here, that this number should be a little bit less than 1, right? So you start to play around with those numbers to generalize and to come up with an approach as to how you're going to remember these numbers. But at the end of the day, they end up being memorized. And that's what kind of makes this hard to teach and to explain. It's just you got to understand the unit circle to get going. Now, one thing to notice is there's definitely some similarities between this point and this point, at least in terms of the degree they open upwards, the height of the point, how far it is away from the origin. And if you can start to come to grasp with, well, if you just know this one and you realize that this one is just mirrored in that opposite direction, normally what you can do is you can realize that, well, I just need to put a negative in front of that first one to pull it back to that other side. And that's really the same thing that's happening here. To move this point over to here, we just negate that x value. To move this point, well, let's even change colors here. To move this point down to here, to flip it down, we just make the y value negative. To move this point over to here, what we do is, again, to flip the x, we just sit there and take the negative away at that point. And really, we can kind of just complete this circle, right? So even though we have 4 different sets of points here, it's really very similar to just one. Let's look at our next triangle here and try to build a little bit more understanding. So here's our next triangle. This was the 45, 45, 90 triangle. Now in this triangle, we know the hypotenuse is 1. If the hypotenuse is 1 and we wish to find the leg length, then what we need to do is divide both sides by the square root of 2. Now, doing that, 1 over the square root of 2 gives us a problem we need to rationalize. So we multiply this by the square root of 2 over the square root of 2, and I end up with the square root of 2 over 2 as that answer. And that is what this is and this is, since we know that these are both going to be the same length. So we have the square root of 2 in each of these situations being divided by 2. Square root of 2 over 2, 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 square root of 2 over 2. And what we're going to do is we're just going to drag these triangles on and figure out where they fit. Now, we should be seeing that very much that same relationship. So when I pull this first triangle up onto my unit circle, I'm looking for a spot where I'm going to have a radius that lines up with the x-axis and where I hit that point. And it looks like I have that happening here. Now, in this situation, if I get this exactly perfect, which probably won't be, but it'll be close. If I get that exactly perfect right there, it looks like we moved over to the right the square root of 2 over 2, and then we went downwards the square root of 2 over 2, so that will give us a negative for our y value. And we can get our next point. Now, just like we did before, what we can do is we can actually just move these triangles around. So we use the first one, now we could grab our next one, and we can actually physically just, oops, hold on, sorry. We can physically put these onto our unit circle to figure out what are the coordinates of each of the points. Now in this situation, we moved positive square root of 2 over 2, so that will be our x value. And then we moved upwards square root of 2 over 2, so that will be positive. Now, if we're looking at this, and we start to think to ourselves, well, if this point is truly just like a mirroring of this point across the y-axis, what changed, right? So the difference between these 2 points, as I can see here, is that this one is a positive square root of 2, and this is a negative square root of 2. So it looks like in order to jump across this line, all we did is we reversed the coordinate that was on the y. So if it was positive, it's now negative. If it was negative, now it's now positive. So let's think about how we could do that over here. So if I wanted to map this point over to here, the middle point's going to always map with that middle point. The y value is still positive in both of these situations. So we're going to still make that positive, and it's going to be a positive square root of 2 over 2. But now our x value, right, this one was to the right, the square root of 2 over 2. This one's going to the left, the square root of 2 over 2, so this is going to be negative over here since we are on the left side of our origin. Now, a couple of things that should happen. When I drag that triangle up here, I should see that same relationship reflected. I think I'm going to need this one. So we should be left so we can see that we did go left, which is why this value becomes negative, and we did go up, which is why that one is still positive. Right, so there's definitely a relationship here, and that's what I'm really hoping to try to get out of this for you, is that you don't need to memorize, holy cow, all of these. What really needs to happen for you is you need to memorize, typically it's just this first quadrant, and then you can just use your mapping skills to sit there and reverse those signs and reverse the order as needed. This thing just will not go away. All right, let's get our last triangle in here. Oops, we still have the bottom one, so let's do it in the bottom one. So if I wanted to map this middle point to its location down there just by reflecting it across the y-axis, when you reflect it across the y-axis, you flip the value of the y. So the y value here was positive, so now we're going to make it negative. So my point here, my x value should stay the same. So it'll be a negative square root of 2 over 2. And now my y value, it was originally positive up here. Now it is going to be negative. Other things that are really important here is like quadrant 3. We know the x is negative and the y is negative. So we can kind of play around with those relationships too. Quadrant 1, we know both the x and the y are positive. Quadrant 2, which is this one over here, we know the x is negative and the y is positive. So we can play around with those relationships too to help us develop this. But at the end of the day, we need to be able to produce this unit circle. Here's the last triangle we're going to be working with. This is also that 30, 60, 90 triangle. It's just oriented a little bit different on our unit circle. So let's get our first one right. So this is going to be our 60-degree angle. This will be our 30-degree angle. The short leg is 1/2, the hypotenuse is 1, and the long leg, just like we found before, is the square root of 3 over 2. So we just want to grab these values for a minute. I want to make sure I only grab those. And when we pull that triangle up here, that triangle is going to be what gives us the location of that last point. So what we can see from this is that the x-coordinate of that point is 1/2, and the y-coordinate of that point is going to be a positive square root of 3/2. Now let's play around with those values to try to map out everything else. Let me get rid of all this extra stuff. So if I wanted to map that point directly across the y-axis there, what I need to do is to change the x value. So my x value was positive initially, now it is going to be negative. So this will be a negative 1/2, and then this will be the square root of 3/2. Now to move this point down to this location, right? Remember the x value here will actually end up being exactly the same. So it was negative 1/2 above. So now it's negative 1/2 here. But the y value is going to be the same distance from the x-axis, just in the opposite direction. So now this will be a negative square root of 3/2. Now the last part of this involves moving this over to here. As you can see, these two values have the same y value already, or those 2 points do. So we can make this one into a negative square root of 3/2. And actually at this point you can even see that if you just follow this down, that the x value here should be a positive 1/2 based on what we already know. And that would make sense because to flip these should be the same distance away from that axis. It's just one's going in the negative direction, one's going in the positive. Now, without a doubt, I know this is a lot of information, but what I really hope you can take away from this is the idea that only this quadrant is the one that matters. As soon as you get that quadrant and you have these values memorized for each of those 3 points, you can use mapping skills to move them to quadrant 2, to quadrant 3, back to quadrant 4, and then back to quadrant 1. So using that information, it's what you need to do now is to go through and actually memorize these. Now at this point, I don't think I really have a homework assignment for you. What I'm going to probably do is post a Schoology assignment that's going to have multiple attempts and honestly is probably ungraded. I want you to practice, and that's really what's most important here, is that you can practice and try to solidify some of these skills. As always, if you have any questions, please reach out, guys. Thank you so much. Have a great day.